Okay, so this is section 8.1 and 8.2, and we're going to kind of talk through these together, and the topic is inverse trig functions. Alright, so first of all, let's talk about a similar problem that we've already done that really is getting at what an inverse trig function is. So we've already looked at problems that ask you to find an exact value. So something like, okay, find the exact value for x. Might be given an interval, let's say from 0 to pi over 2, when cosine x is equal to 1/2. Alright, so what did you do? Basically, we were looking for the angle, right? So cosine of what is going to give me 1/2? And what we did before is we set up our triangle. Okay, since this is from 0 to pi over 2, that means we're going to be in the first quadrant. So here's my triangle. Here's my angle. So adjacent over hypotenuse. So this side would be square root of 3. So I know that x must be 60 degrees or pi over 3 radians because I'm familiar with that triangle. So what an inverse trig function is another way to say that is, okay, x is equal to cosine inverse of 1/2. So cosine inverse of 1/2 is the same as cosine x is equal to 1/2. So those two things mean the same thing. Alright, so next what we want to talk about is really how to define an inverse trig function. So to define, let's think about what we already know. So we've already talked about inverse functions in algebra. So let's think about what we already know about inverse functions. Alright, so for one, inverse functions are one-to-one functions which mean they pass the horizontal line test. So remember that in order for a function to have an inverse, it has to be one-to-one. Okay, number two, graphs of functions and their inverses are symmetric with respect to the line y equals x. We know that when we compose a function with its inverse, either way, the function is just, the composition is equal to x. And we know that the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. Okay, so keeping that in mind, if we're going to define inverse trig functions, for one, think about this first point here. They have to be one-to-one. What does the sine curve look like? What does the cosine curve look like? Right? If I'm just going to sketch a curve for sine, it's going to go like this. So is that a one-to-one function? Would that pass the horizontal line test? Would that horizontal line only intersect the graph in one spot? No, it certainly wouldn't, and it wouldn't with cosine or either of their reciprocals. So what we have to do is we restrict and only look at part of the trig functions to build an inverse trig function. So let's start with y equals sine x. Okay, so we know what that looks like. Y equals sine x. Let's think of our key points. We'll take it out to 2 pi. So this would be pi over 2, and 3 pi over 2. If we want to start to go to the left a little bit, this would be negative pi over 2, negative pi. All right, here's 1, here's negative 1. So we know we start at the origin, we go up, center, down, center. If I'm going to continue this way, we would be down, and then center. So right, the graph looks like something like this. Well, we only want to look at a piece of this graph. We are just going to look at from here to here. So we're just going to restrict the domain and only look at the graph from negative pi over 2 to pi over 2. So the range, again, is that lowest point is negative 1, the highest point is 1. So if we just consider that much of sine, when we look at the inverse trig function, so that is y equals sine inverse of x, let's think about what the domain and range of the inverse function is. The domain will be the range of what we're using for sine x. So that's from negative 1 to 1. And the range will be from negative pi over 2 to pi over 2. So the values, the y's, can only be between negative pi over 2 and pi over 2. The x values will be in between negative 1 and 1. All right, let's do the same thing for cosine. Oops. All right, so y equals cosine x. We're going to restrict it similarly. So, okay, here's our graph. We could go out to 2 pi. Here's 0. So in the middle will be pi over 2, 3 pi over 2. Over here we'll have negative pi over 2, negative pi. Okay, up to 1, down to negative 1. Cosine starts up. And then we'll follow our pattern. All right, so our graph looks like this. Okay, so now, again, I can't restrict this one from negative pi over 2 to pi over 2 because that piece of the graph wouldn't be 1 to 1. So I'm going to restrict from 0 to pi. So my restricted domain will be from 0 to pi, and again the range is still from negative 1 to 1. So what does that mean for y equals cosine inverse of x? So that means that the domain is from negative 1 to 1, and the range is from 0 to pi. So again, how this comes into play is, since the inverse function is really representing the angle, so that means when I'm coming up with a value, that I'll be restricted when dealing with cosine inverse from 0 to pi. So that'll always be an angle in either quadrant 1 or 2. Unlike sine, since I restricted sine from, let's change the color. We restricted sine from negative pi over 2 to pi over 2. So that means that that angle is restricted to either the first or the fourth quadrant, depending on whether it's positive or negative. All right, let's talk tangent and cotangent, and then we'll work with some examples. All right, so tangent. Y equals tangent x. So let's look from negative pi over 2 to pi over 2. Remember, that's where our asymptotes are. So the graph looks something like this. And that section of the graph from negative pi over 2 to pi over 2 is 1 to 1. So we can restrict the domain, like sine, from negative pi over 2 to pi over 2, and that would, again, the range of tangent is from negative infinity to positive infinity. So what that does for the inverse function is it gives us a domain of all real numbers and a range of negative pi over 2 to pi over 2. So if we go back to what we were talking about up here, again, maybe we'll make tangent in green. So when I'm looking for angles for tan inverse, again, since I've restricted from negative pi over 2 to pi over 2, I'm looking at angles in quadrants 1 and 4. So again, if I'm looking for a positive angle, it will be in quadrant 1. A negative angle, it will be in quadrant 4. And finally, let's take a quick look at cotangent. All right, so cotangent, like tangent, if we're just looking at one period of the graph, it is 1 to 1. So cotangent looks like this. So I can restrict my domain. I'm just going to put RD for restricted domain from 0 to pi, and then the range, again, is all real numbers. So what that does for the inverse function is my domain is all real numbers, but my range will be just from 0 to pi. So it doesn't behave the same way as tangent. If we go back up here to where we were charting this out, so tangent we restricted from 0 to pi. So again, if it's positive, quadrant 1, negative, quadrant 2 for cotangent. Now the reciprocal functions, aside from tangent and cotangent work differently. Tangent is restricted to quadrants 1 and 4, cotangents to 1 and 2. But now sine and its reciprocal will work the same. So sine and cosecant are restricted to quadrants 1 and 4. And cosine and its reciprocal, secant, are restricted to quadrants 1 and 2.